videos for Edline. And we're now going to look at the derivative with respect to x of the cosine of x. And again, we're going to use what we used in our previous problem. When we were finding the derivative of the sine of x, we're going to use the limit as h goes to 0 of the difference quotient. And here's our earlier computation here. Okay, so I'm going to add a page above. And let me paste this in. There's a limit as h goes to 0 of the difference quotient. So what we're going to do is we're going to find the limit. My font's a little too big. Let me fix this. Back out. So we want the limit as h goes to 0 of the difference quotient for the cosine of x, because we're looking for the derivative with respect to x of the cosine of x. And what is that going to give us? So we're going to say the cosine of x plus h minus the cosine of x all over h. Oops. Let's fix our h. I had the straightener on. Okay, so I'm going to zoom in on this a little bit. And we hopefully remember from pre-calculus how to expand the cosine of x plus h. We have looked at it as expanding the cosine of a plus b. So I'm going to copy this. Let me copy this and paste it, the first part. And we're going to expand the cosine of x plus h. And that's going to be the cosine of x times the cosine of h minus the sine of x times the sine of h. And so this right here is expanded like this. Okay? And then of course we've got to throw on the end there minus cosine x. So let me get rid of the highlighting and finish this off. I have to say minus, oops, wrong font. Okay, minus the cosine of x, and let's continue this, is equal to, let's see, I'm going to do what I did before, which is do some commuting. So if I'm going to commute, you really have to have it become all addition. So let's say this is add the opposite, and now I'm free to commute. So let's see, I need the limit. And when you're doing this on the AP exam, don't take shortcuts and not write the limit each time or you'll lose points, okay? Because the limit is a limit until it's fully resolved. Okay, so let's say, I want to put the cosines together. So I'm going to start with the cosine of x times the cosine of h. And I'm going to add the last term, the negative cosine of x. And then I'll add the middle term. So the middle term is going to the end, the sine of x sine h. It looks like, yeah, that's good. Okay. So now the next step, it's very similar to when we found the derivative of the sine function. We're going to factor out the cosine of x, and we're factoring, the cosine of x out of these two terms, from these two terms. And if we factor out the cosine of x, we end up with cosine of h minus 1. So what's left is the cosine of h minus 1. And then, of course, we have to add a negative sine of x sine h. And hopefully, as I'm doing this, because you just saw me do the other derivative, which is very similar, it's derived the same way, you're maybe speculating what's coming next. Okay? Getting a pretty good feeling. Let me move this up. Okay. Now, the limit of a sum is the sum of the limits, right? So what I'm going to do is I'm going to divide this into, well, separate this, I should say, into the sum of two limits. And the first one is the sum of the limit of, as h goes to 0, the cosine of x times the cosine of h minus 1 all over h. And I'm going to add to that the limit as h goes to 0 of a negative sine of x, sine h, over h. You okay? All right, and now the next one, and then this one here, I can factor out the cosine of x because there's no h in it, and here I can factor out a negative sine of x because there's no h in it. Does that make sense? Okay, so that's what I'm going to do. Matter of fact, I'm going to take this whole thing. Let me just take it, copy it, and paste it. Copy and paste it. I have to hurry up because Katie's laughing. I'm afraid I'm going to lose her. Okay, so I'm going to take the cosine of x and move it over here. I've factored it out. I'm moving this over a little bit. And it's a little crunched, so let me move it to the right. Okay, and now I'm going to take this second term. It's going to disappear for a minute. And I'm going to factor out a negative sine x. Move that over. And hoping you can all see what I did is a little, unfortunately when I move these they disappear until I put them back, but I took the cosine of x, factored it out, and the negative sine of x, and I factored it out. Make sense? Yeah? Okay, so now what? Well, what is the limit as h goes to 0 of the cosine of h minus 1? 0. So what happens here is this goes away. Let me throw up a, let's see, let's put a line that this goes to 0, so this is all gone. What is the limit as h goes to 0 of the sine h over h? 1. So that means, remove the highlighting, that what's left is the negative sine of x, right? Negative sine of x times 1. Okay, so the derivative of the cosine of x is the negative sine of x. We just derived it. So you can put that up here. It's the negative sine of x. And if we go back to our previous diagram here, we can fill this in. The derivative of the cosine is the negative sine. So if you look, in fact, at the cosine of x and the sine function, whatever we have, whatever the height of the sine function is, if you multiply it by a negative, you have the slope of the cosine function. We need to memorize these.